This is the new topic. What happened of a transformer if we supply your DC source or DC supply primary of a transformer? What happened if DC supply to primary of a transformer? So finally, if the transformer has basically two winding, one is primary winding, another is secondary winding. Primary winding and secondary winding isolated in electrically and magnetically linked, for which if someone connected to DC supply of a transformer in a distribution transformer or power transformer, what happened exactly? So normally this is a transformer, this is known as a normal transformer or two winding transformer. This is the primary winding and this is the secondary winding. The secondary winding always connected to load, that means the load is connected winding is known as secondary winding and the supply connected winding is known as primary winding if we supply the DC source. The primary winding have some practically resistance and reactance are there, which is called as a practical transformer. We have in primary side some resistance are there or some reactance are there. Similarly, in case of secondary side, some resistance are there, namely R2, and some reactance are there, in name is X2. That means in the practical transformer, have some voltage drop across primary side, also some voltage drop across secondary side due to the winding resistance and winding reactance. If someone supply to a DC source, that means DC voltage, at the same time we know that induced EMF E is equal to minus N d phi divided by dt. This is the primary voltage induced EMF. E is equal to minus N d phi by dt, where d phi by dt is the change of flux with respect to time. This is the Fleming. This theory is basically Faraday's laws of electromagnetic induction. First law. Here Faraday's laws, two types of first law. One is for dynamic. Dynamic means where the rotating part are there. This is known as dynamic. And another is static device. That means transformer is a static device. That means according to Faraday's laws of electromagnetic induction, EMF induced by dynamically, it is used as a transfer generator and motor, and another is induced EMF statically, which is used as a transformer. That means whenever a conductor cuts the magnetic line of induced EMF, this is known as a dynamically induced EMF, and another is when a flux linked with time changes, EMF induced in it, this is known as the statically induced EMF. Here E is equal to minus N d phi by dt. Minus sign is for Lenz's law and N is the number of turn. So finally E is equal to minus N d phi by dt. If someone places the DC source, then the change of flux with respect to time d phi by dt is equal to 0. And finally the E is equal to minus N into 0. And finally induced EMF is equal to 0. If the primary side induced EMF is 0, at the same time the current is high. At the time the primary current I1 is high, and at the same time the primary winding may burn out. So if someone supplied a DC supply to a primary winding, at the same time the primary winding of a transformer may burn out due to there is no changes of the flux linkage and induced EMF approximately 0 and current is high and winding may burn out.